Okay, so I just wait a little bit for you to be able to join. Yeah, I would appreciate if you can share the link with everyone, because I saw that on Zoom you are 15, but now I see only 9 people are here. I just wait a little bit and then I start the new lesson. And then if suddenly someone comes in, we end the meeting, okay? I am actually tired for looking at the empty classroom now. Okay, today's topic is the equation of this form. So the topic of lesson today is the equation z to power n equals to w. Here, n is a natural number and z and w are complex numbers. Okay. So this is a very important topic. So we want to understand how we can solve this equation in the set of complex numbers. Yes? And I think the best way to teach this is to start with an example. For example, I ask you to solve this equation, z to the 3 is equal to 8. In the complex numbers, of course. If I ask you this question and I ask you to solve this equation in the set of real numbers, it is super simple, yes? There is only one real number satisfying this condition, and that is clearly 2, yes? 2 to the 3 is equal to 8. 2 times 2 times 2 is 8. And of course, 2 can also be viewed as a complex number, yes? 2 is 2 plus 0i. So every real number indeed is actually a complex number in the first place. So if you say solve this equation, you should expect still to get the same number as one of the roots here. But if I just limit myself to the set of real numbers, you know that there is no other real number, so that when I raise it to power 3, the answer becomes 8. But you will see that there are other solutions if you want to solve the same equation, but in the set of complex numbers. And this is a little bit technical, so I want you to learn how to do this. Okay, so let us start. I will write everything down patiently so that you can follow the logic, and then we can solve different problems to learn how to deal with the problem in different situations. The important thing here is the Demoir formula, actually. So here we say that I am looking for this x, for this z. I start with this sentence. Let the number that I am looking for has this polar form. Let z be equal to r times cosine theta plus I sine theta be the complex number z. Be the solution. Be a solution. Okay. If I ask you, so you know that this is a complex number, and we learned that every complex number can be written in the polar form. And this number that you see here is a real number, and it's a positive number. And this number that you see here, which is called the argument, is an angle between 0 up to 2 pi, according to the convention that we are using in this lesson. Okay. And then I am looking for this z. In principle, it means that I need to give you the value for r, and I need to give you the value for theta. Because I am looking for z, I have just written z in the complex, in the polar form, but still r is not known, theta is not known. If I want to give you z, I need to give you what is r and what is theta. In that case, I can claim that z is actually found for me. Okay, but then what you need to do, this is supposed to be a solution of this equation. So it means that this solution satisfies this equation. So instead of the z in the equation, I write this. And when I want to raise it to power 3, we learned how to do it in the previous session. I raise r to power 3. So let me write it here. Z to the power of 3 is equal to 8. This implies that r to the 3. And then you know that if I want to raise this to power 3 according to the de Moivre's formula, I need to just multiply 3 by that argument. And this is equal to 8. So I want you to understand now the logic. On the left-hand side, you have a complex number. On the right-hand side, you have also a complex number, but of course, this can be viewed as 8 plus 0i. That's also a complex number. If this complex number is supposed to be equal to this complex number, I can immediately conclude that its absolute value on the left, the absolute value of the number on the left, should match with the absolute value of the number on the right. But if I ask you what is the absolute value of this number, hopefully you agree with me that number is R3. So this means that this implies that R3 should be equal to the absolute value of this number, which is 8 here in this case. Okay? And then if I ask you what is R, you would say R is 2. Here, you might confuse a little bit yourself. You say that, okay, what is the difference between this equation and that equation? They are exactly the same equations. The only difference is that I have changed the letter, my variable, from z to r. No, it is more than that. Here, z is a complex number. We don't know if all the answers are real. But here I know r is real and is positive. So it's not a circular argument. I want you to understand that. Even though the equation I get at this stage is very, very similar to the equation that I started with, the only difference is that instead of letter z, I have letter r. You might think that I am doing a circular argument. No, here I am looking for complex number z, but here I'm not looking for complex numbers r. Because r is absolute value of z, I have a little bit more information about r, and that is r is real and positive. So let me emphasize here that because r is real and is positive, there is only one chance for r, and that is equal to 2. And then what you do, you plug this back into this equation. So instead of r, let me just do it patiently because I don't want you to lose the logic. I put 2 here, so it becomes 2 to the 3 cosine theta. So you see, this question mark is solved. I was looking for r and theta, now r is found. My duty is now to find theta. For finding theta, I put it back into the equation. So it becomes 2 to the 3 cosine 3 theta I sine 3 theta. On the right-hand side, I will have 8. But you know that 2 to the 3 is 8. I can cancel 8 from both sides. So this is 1 times, and I divide 8. This is also 1 times. So what is left for me? What is left for me is this. Cosine 3 theta plus I sine 3 theta is equal to 1, but 1 can be viewed as complex number, 1 plus 0i. And now you see that on the left-hand side, I have a complex number. On the right-hand side, I also have a complex number. They are supposed to be equal. So it means that I can conclude something about theta. The real part of the left-hand side, which is cosine 3 theta, should match with the real part of the right-hand side, which is 1. and the imaginary part of the left-hand side should match with the imaginary part of the right-hand side, which is 0. So you see, I have 2 question marks to answer. One of them I already answered. So I need to use these equations to find my theta. Okay, so I am looking for an angle whose cosine is 1 and its sine is 0. So if you just roughly draw this unit circle, so you know that cosine is related to x coordinate and sine is related to the y coordinate. So it means that this point that you see here has x coordinate 1 and y coordinate 0. So what is the angle corresponding to this final point? I just connect it to the origin, and then you see that that angle is 0. So this implies that from this equation, from these 2 equations, I get that 3 theta is 0 degrees. Let me write degrees in this case now. Or let me write it in radians. So 0, but 0 is not the only angle, yes, because I can go 1 full round in this direction or in the opposite direction. I can go 2 full rounds. So 3 theta is not only 0, but plus 2n pi, yes, where n is an integer. Okay, so it means that 3 theta is equal to 2n pi, but I am looking for theta. So theta becomes 2n pi divided by 3, n belongs to z. So I got infinitely many answers. Okay, but those infinitely many answers don't give rise to infinitely many answers for z, because my point is to find z. It's not my direct goal here. This is an intermediate goal. My final goal is to find z. For finding z, I need to find r and theta. So what matters at the end for me is not theta, is z. Why I'm saying this? Because z is expressed not in terms of theta directly. It is expressed in terms of cosine and sine of an angle. And you know that if this angle ends up at the same point on the unit circle, even though it might represent a different angle, but cosine and sines are the same, and when I put them here, I get the same value for z. So it is completely clear, even though I got infinitely many answers for theta, this doesn't necessarily produce infinitely many answers for z, which is important for me. So let us understand this problem a little bit better. So for example, let me start with putting n equal to 0. Because n is an integer, let me start with non-negative integer first. Not negative integers, the smallest one is 0. So this implies that theta, when I put 0 here, this is totally gone, it is 0. So this is exactly this point. And let me put n equals to 1. What happens? Theta becomes 2 times 1 times pi, 2 pi divided by 3. It is 120 degrees. More or less, it is something here. Okay? Do I need this point? Yes, because this point, the final point is different. When the final point is different, it means sine theta and cosine theta are different numbers than the numbers here. This means that I get a new number for z because sine and cosine are different. Okay, let me check another point. If I put n equals to 2, then what happens? Theta becomes 4 pi over 3. It is 240 degrees. So it would be here, for example. So this is 0. This is 120 degrees, which is 2 pi over 3. And then this angle, bigger angle, is 4 pi over 3. But look what happens. If I put n equal to 3, even though I am getting a different angle, no doubt about it, it becomes 2 pi. And 2 pi is not already in my list. These are all different numbers. But 2 pi ends exactly at this point. So if I put 0 here, I get the same pair of numbers for cosine and sine as if I put 2 pi. So for solving that problem, I don't need to continue more, because if I start adding numbers, I jump from this point to that point to this point, again to this point. So it goes like that. So it will not produce you more than 3 final points, even though it produces you infinitely many angles. But all of them fall into 3 categories. Many of them will, infinitely many of them will be here, infinitely many of them will be here, and infinitely many of them will be here. And what matters for me are just the final points. So in total, if I ask you how many angles I need, I will just take these 3. I don't need to continue anymore. Okay? Now everything is ready. I go back here. So remember, these are my values for theta, and I just got one value for r, and that is 2. So it means that I choose r equal to r equal to 2, and then theta equals to 0. This gives me one root. I choose r equal to 2, and theta, this number, it gives me another value for z, another complex number. And I choose r equal to 2 finally, and choose theta equals to that, and I put them in that, I will get my third solution. Yes, that's it. I don't need to continue. I want you to understand why we don't need to continue the angles. Okay? So let me just now solve the problem finally. Okay? So I would say now the final answer is that r is 2, theta is 0. This gives rise to z equals to, instead of r I put 2, instead of theta I put 0. Okay? But whenever you can calculate these numbers, it is better to calculate them. If they are approximations, then you need to see. If I ask you for decimal points, then yes, you need to calculate them using decimal points. Otherwise, just leave it like that. But cosine of 0 is famous, yes? Cosine of 0 is actually 1. Sine of 0 is 0. And then it becomes exactly 2, as you predicted from the beginning, yes? We realize that one solution is 2, and it's still one solution is 2. But in real numbers, that was the only solution. But in the set of complex numbers, we have 2 more solutions. One of them corresponds to this value for 2 pi over 3. And then I put it here. So z becomes 2, and then I have cosine 2 pi over 3 plus I sine 2 pi over 3. Yes? But these are famous angles, so you can calculate them using your trigonometric knowledge or using your calculator. So this is minus 1 over 2. This number is the square root of 3 over 2. And now I multiply 2 inside. So here I got z equals to 2 as one solution. And here I get z equals to, I multiply 2 inside. It becomes minus 1 plus the square root of 3i. This is the second solution. And then another solution is this, 4 pi over 3. And then I put it again in the equation. So let me write with blue, it's fading out. So z is equal to 2 cosine 4 pi over 3 plus I sine 4 pi over 3. But again, you can use your trigonometric knowledge to calculate the exact value here, because this is just pi plus pi over 3. And if you remember from trigonometry and using symmetry, you can immediately calculate what happens for this. But if I do that, it turns out to be minus a half again. But this one also becomes minus 3 square root of 2. And then when I multiply 2 here, so let me write it with black again here. So it becomes minus 1 minus the square root of 3i. And there are no other solutions for this equation. So this problem, even though very simple in stating it, it's just, I don't know, one very simple equation, but it is a little bit technical to come up with all possible answers. Okay? And then this is also important to know. If I ask you, if I want to draw the graph of these on a circle, I would say that if I ask you what is the absolute value of this, it is 2. Absolute value of this is again 2. Absolute values still are. If you don't believe, calculate. The square root of this one to power 2 plus this one to power 2 becomes the square root of 4, which is 2. And that's also the same. So it means that these 3 points all lie on the same circle, centered at the origin, whose distance from the center, whose radius is actually equal to 2. So it is also good to understand it from geometrical picture. If I ask you to draw this on the complex plane, so you can just do something like this. So you draw a circle of radius 2. This is a circle of radius 2. This angle, this complex number is here. Be careful, the radius is 2. Yes? And then this one, the radius is still, the absolute value is still 2, so it lies somewhere here. But what is the argument? The argument is 120 degrees, so it is somewhere here, if this is 120 degrees. And then the other one is this one, so the absolute value is still 2, but the argument is 240 degrees, which is here. And then this is always the case. If I connect these 3 points, it gives rise to a regular polygon. Here, in this case, our regular polygon is an equilateral triangle, a triangle whose sides are always the same. And this is also very, very important to know. If I ask you how many roots this equation does have, how many roots does this equation have? In complex numbers, it's always equal to this number on top of that you see. If this exponent is 3, I will have 3 roots. If this exponent is 4, I will have 4 roots. And the roots will be on the circle again, depending on this number, what that is. They all lie on the same circle with the corresponding radius, which is equal to the absolute value, corresponding absolute value. But if it is 4, if I find those points and connect them together, it becomes a regular polygon. But here I have a polygon with 4 sides, so it becomes a square. If I have z to power 5, and then I find all the possible answers, there are 5 answers exactly in the set of complex numbers. And then if I find them on the circle of the corresponding radius, which depends on the absolute value of that number, they will be points that if I connect them, it becomes a regular polygon. But here, because this power is 5, it becomes a regular pentagon. Yes? So this is an extremely important to be able to visualize it geometrically. Okay. I think this is technical, so we need to solve more problems to understand what's going on. Okay. But if you have any questions, please let me know through Zoom. I cannot see the chat, but I can hear you if you have any questions. Okay. So let me solve. Let us see how much time we will have before someone comes to the lesson, to this classroom. But let me just start solving at least one more problem for you. Okay, I want to change this equation a little bit. So, by the way, I forgot to say something. It's not in the book probably, but the root that you get for n equal to 0 is called the principal root. Okay, I will explain it. Let me see if I have something here. Yes, let me change this refill. Okay, so let me ask you to solve this problem. For example, let us go z to the power of 4 And on the right-hand side, let me just write 1 plus I. So one thing I want you to understand is that technically you might say that z is equal to the fourth root of 1 plus I. Why we shouldn't write it like that? Yes, in principle, you should be able to write that. But the problem is that the fourth root of a complex number, a fourth root of any number in a set of complex numbers is not a unique number. So this is why sometimes people write, when I write the square root of 4, in some books you might even see they are writing plus and minus 2. And this is correct if you are working in the set of complex numbers. But in the real number, if you put this in your calculator, you always get, it doesn't matter how many times you punch this in your calculator, you always get positive 2. Never you will get negative 2. But I don't know, if you see something like this, this is not valid if you're working with the real numbers. But in the set of complex numbers, if I ask you what is the square root of 4, I am not asking for the positive one only, I am asking for all possible ones. And because this is the second root, according to what we told here, there are 2. Here, you expect to have 4 solutions. I told you, if this power is 4, there are 4 solutions. Here, even probably you cannot guess even one of them. If I ask you, can you give me a complex number so that when I raise it to power 4, it becomes this? It might be not that easy, yes? So let us try to solve this problem now. The point is that your starting point is here. You would say let z be equal to r times cosine theta plus I sine theta. Okay? And then still you know that 2 pieces of information are missing. I need to address these 2 question marks for you. What I do, I plug this back into this equation. So let me write it more clearly. So I would say that now z4 is 1 plus I. So this would imply that I raise this one to power 4, it becomes r to the 4. Let me not repeat these things. According to Demoir's formula, I just multiply 4 here. So it becomes cosine theta, 4 theta, cosine 4 theta plus I sine 4 theta equals to the right-hand side, which is 1 plus I. So this is crucial to understand the logic. I have a complex number on the left. I have a complex number on the right. If 2 complex numbers are supposed to be equal, it is clear that the absolute values should also be equal. The absolute value of the left-hand side, hopefully you know, is r4. Yes? So this means that r to the 4 is equal to the absolute value of this number. Absolute value of that number is a square root of 1 to the 2 plus 1 to the 2. So it becomes a square root of 2. So r to the 4 is this number, but I am looking for r. But be careful, r is absolute value of this complex number. So definitely it is not only real, but it is also positive. Yes? So then r to the 4 is the square root of 2. I am looking for a real positive number whose 4th power is equal to that. So this means that r is equal to the 4th root of a square root. I do not put plus and minus because I know that r is positive. I am taking the 4th root of already a 2nd root. So this becomes the 8th root. Yes? If you want to understand that, let me explain. So the 4th root of the 2nd root of 2 is the 4th root. Instead of the square root of 2, you can write 2 to the power of 1/2. But then again, this becomes 2 to the power of 1/2 to the power of 1/4. But then 1/2 and 1/4 are multiplied, it becomes 1/8. Then you can write it back in the form of a third sign. So yes, From these two question marks, I was able to find r. So let us put it in a box for future. Yes? And now I want to calculate theta. So how should I calculate theta? I have to plug this back into my equation. So here you have to be a little bit careful. So I plug this back into my equation. Okay, so instead of r, I put this one. So if I ask you, okay, so let me put it there. So it becomes the 8th root of 2 to power 4. Instead of r, I put in this number. And then multiplied by cosine 4 theta plus I sine 4 theta. And on the right-hand side, I will have 1 plus I. But if I ask you calculate this, you should be able to calculate this immediately, yes? This becomes 2 to the power of 1 over 8. And then I have it to power 4. So this becomes 2 to the power, I multiply them, it becomes 1 over 2. So it is nothing except the square root of 2. So this number is just the square root of 2. And then I divide everything by square root of 2. The left-hand side becomes cosine 4 theta. The right-hand side, I have to divide this by square root of 2, and I have to divide the other one by square root of 2. Understandable? If you have any questions, please let me know through Zoom. Okay, now I have a complex number on the left, and I have a complex number on the right. They are supposed to be equal. So it means that the real part of the left-hand side, which is cosine 4 theta, should match with the real part of the right-hand side, and the imaginary part of the left-hand side should match with the imaginary part. Okay? So now, this is actually a famous angle. That's not hard. If I ask you cosine, can you give me an angle whose cosine is 1 over a square root of 2 and simultaneously its sine is also 1 over square root of 2? If you know these numbers, these are famous numbers, you immediately realize this. By the way, this is important because both of them are positive. So this angle should lie in the first quadrant because the cosine is positive, the sine is also positive. And then that angle is a famous angle. So this is a unit circle. So I go to the unit circle. I don't know if you remember, this angle relates itself to 45 degrees. Yes. So this means that 4 theta is 45 degrees. Let me write it in radians. But not just 45 degrees, but plus any multiple of any even multiple of pi. N belongs to z, and then I divide by 4, so theta becomes 4 pi over 16. I divide this by 4, it becomes n pi over 2, n belongs to z. Again, the same idea, the same scenario. You see, I've gotten infinitely many possibilities for theta. But needless to say that not all of them is acceptable. A rule of thumb is this. Start putting 0, 1, 2, 3. You go up to 1 unit less than this 4. Because I told you that from geometrical point of view, it's a good picture to have. They will give you 4 points. So it means that 4 of them are acceptable. Always start from 0. 0, 1, 2, 3. So there are 4 numbers. Okay? So, and then, of course, I don't want you to memorize that. I want you to understand. Why? Because if I put 0, theta becomes pi over 16. If I put n equals to 1, then theta becomes equal to pi over 16 plus pi over 2. If I add them, it becomes 9 pi over 2. No, 9 pi over 16, sorry. Yes. And if I put n equals to 1, then theta becomes pi over 16 plus, no, sorry, I have to put 2. it becomes plus pi, and then if I add them, it becomes 17 pi over 16. And then if I put n equals to 3, I get theta is equal to pi over 16 plus 3 pi over 2. And if I add them, it becomes 25 pi over 16. Am I right? Yes. And now, if you insist to give you one more to continue, you will start not repeating the same angles, but you will start repeating the same final points. Of course, it is hard for me to draw it precisely. Pi over 16 is 1/4 of 45 degrees. So assume that we have something like this. Assume that this is pi over 16. And then the other one is 9 times larger than that one. So it goes here. Yes. And the next one will go here. And the next one will go here. And then if I have done it correctly, it's a very bad picture. But this is a really, really bad picture because it's supposed to be a complete square. It's always a regular polygon. Okay. So, yeah. It's very hard to draw it precisely here, but I want you to understand. Of course, I'm talking about theta. Let us draw it later, okay? Because the absolute value is also a strange number, yes? So the absolute value is the 8th root of 2. Okay, but if I continue for that, I will get a different angle, of course, but that angle, final endpoint of that angle matches with the final point of this angle. And what matters for me are the final points, not the size of the angles. Because if the final points are the same, sine and cosine are the same, and then this gives rise to the same z. So theta is not my main goal. The reason that I was interested in finding theta because I plugged them here and I found my z. And z is not very sensitive to theta. It is sensitive to cosine and sine of the theta. So if I return back to the same final point, I will get the same value for z. So this is why I do not continue. By continuation, I will repeat the same final points as these angles. Okay? Okay, now you see that you were not able to even guess those numbers. So we are solving it systematically. So what I need to do at the end, I need to write my answers. So remember, this r is this number. So what I have to do, let me clean this. I would say that r is equal to the 8th root of 2, and theta is equal to that number, pi over 16. So one root, so let me call it z1, root number 1, is this strange number. Cosine pi over 16 plus I sine pi over 16. This is the number, and it was not easy probably to guess at all. Yes? And you don't need to do more than that unless you want to have an approximation for it. If you want to have an approximation, you put this number in the calculator, you get an approximate value. You put these numbers, you get approximate value in the radian mode, of course, here, and then you multiply. That number is an approximate answer, one of the approximate answers to this equation. And then, of course, you need to write the other ones. So you would say that r is the 8th root of 2, and theta is, the other number is what? 9 pi over 16. And this gives me the second root, which is the 8th root of this, and cosine of 9 pi over 16 plus I sine of 9 pi over 16. I want you to understand that we were successful. Might be you say that what type of answer is this? Who knows about these numbers? But yes, whatever you need to know about these numbers, you can. This is the exact value if you are interested. If you want an approximate value, then you put this in the calculator and find an approximate value. And the interesting thing is that if you see none of them is real, and this is clear because there is no real number when raised to power 4, it gives me a complex number. Yes. So you should be able to see this before even starting that. But the important thing is that, again, you see that I have 4 solutions. When this power is 4, I get exactly 4. So the 8th root of 2, and theta is the other number, so 17 pi over 16. So this means that z3 is the 8th root of 2, cosine 17 pi over 16 plus I sine 17 pi over 16. This is the next one. And finally, r is the 8th root of 2, and theta is 25 pi over 16. This gives me z4 is equal to the 8th root of 2, and then cosine 25 pi divided by 16 plus I sine 25 pi over 16. So that's it. The end of the solution is this here. So this is your answer that you get. So these are the 4 possible complex numbers that you get by solving this equation. Okay? I think of course, complex numbers are very broad, so we can bring a lot of examples. And still, I really don't know, might be in 5 minutes, there will be another teacher coming in here, because according to what is written behind the door. So I think that it is better to stop here. There is only one part of this is left, and next week, as I saw the program, actually you will be physically in a school, so we will actually use 1 session to finalize, or 2 sessions to finalize, yes. And then we still have another week. So in that week, we can solve harder problems together and try to enjoy more harder problems there. So if you don't mind, let me just end the video and the meeting here. And then I don't have Math 4 book with me, so you can go, and the title is this, the equation Zn to the power of n is w. Read the text if you want to, and then try to solve those problems, and then we complete it next time. Okay? I will end this stream, thank you, but I will be available in Zoom for some minutes if you have any questions, and then we completely end the meeting. Thank you.